Boom. Get rid of our box collider. Sorry, yeah. Okay, so that'll make a difference. The other trick that's worth highlighting, because rendering is, see now this is all of a sudden a whole lot smoother. We're getting about 30 FPS, right? But still, so even though it's a bit smoother, it's still a bit janky. One trick, because this is a floor that's moving, I can go to the camera and, all right, where's my camera? Here we are. All right, so this depth is part of the thing. If I really want this just to be a horizon, right, a floor up to a certain horizon, so I can improve the performance by changing the clipping. Now, that may cause other issues, but for instance, now if I hit play, the performance is now 100 FPS, right? The number of objects is the same. All I've done, if I move far up, you can see the clipping plane kicks in here, right? But if it's a floor, and if I've limited the height, right, that means I could still have a convincing horizon, right? So it still looks like a convincing horizon view. These objects are still there. So as I move forward, they come within the clipping plane.
Right. Oh, look at that.
Right. And you've still got about 90 FPS, maybe 80 FPS, right? And that's still
awesome.
with 40,000 objects, right? So now we've just hit the end. But I could potentially have a lot of objects now, right? Like I can go quite nuts. So in terms of the number of rows, let's make it 2,000, see what happens. Have I tried this before? No, let's give it a shot. But because of the clipping, it should work. Okay, the startup time is a bit of a killer. And we can see here we've created 400,000 objects. It should be enough for anybody. Okay, that has murdered the frame rate. It is 60 FPS. That's interesting. Actually, it'll be interesting to see what's...
Okay. Yeah, so look at that. It's all of it is just from GPU.
Yeah, most of it's in the rendering, exactly.
Yeah.
There is a bit more work going on in the jobs now. But all right, nearly 500,000. I'm not,
Oh yeah.
How can I complain?
No, yeah. This was good. This was awesome. This is awesome. It's informative. I'll make sure we send out the link to this to everyone. I'm also gonna upload this to our YouTube channel and make sure that I'll stitch together everything and make it look awesome. Dude, man, Warwick, man, thank you so much for coming on today. I mean, this was so cool. I think there was a lot of valuable lessons learned for the job system. I think it was a great idea seeing multiple tasks, multiple jobs. Really, really cool. Yeah, thank you, dude, so much for coming out.
Oh, thanks for having me. It's been fun. I've really enjoyed it.
Yeah. I definitely think we'll see more of you on with us and getting more insight into the job system and dots and beginning a proper learning journey through you for ECS. For everyone who doesn't know, again, this is Warwick Malloy. He is a brilliant software engineer. He's been doing this for 35 years, 25 years professionally, and he knows he's been studying the dots and ECS system and C# job system in and out. So make sure you guys are subscribed to his YouTube channel. Again, that is Designer Tech here.
Yeah.
So just subscribe to Designer Tech. He has amazing content on A-Frame, which is it's the ECS for WebGL. And then he has a ton of content on here related to programming with dots and ECS and job system. So really, really good content. Make sure you subscribe to him. We'll be having him back for sure and collaborating with you on some really cool stuff, because I think there's a lot to explore within practical use cases of the C# job system. And I think definitely I speak for everyone. I think the whole community really enjoyed this.
No, thank you. I had a blast. So it was great.
So there is one last question actually that I've been wanting to ask. I'm surprised no one else asked it. So Warwick comes from a very academic background, I assume. Did you graduate? Do you have a master's degree or a bachelor's degree in programming?
So I did a bachelor's in engineering,
Mm-hmm.
which is electrical and computer systems engineering. That was from 1990 to the end of 94.
Okay.
And we had to do, all kinds of, the first couple of years you have to do everything, including like chemistry and so forth.
Right.
So lots of physics and that, so a fair bit of maths, and looking at processor design, state machines, So that gave me a lot of structure in the way I think about things. And state machines are actually awesome. So there's a whole thing we could talk about in state machines. If you think of Playmaker and it uses state machines, I don't like their model. It's not bad, but there's a better model of state machines than that. In fact, the talk that I was giving, that the professor came along and saw me and recruited me for Monash, I was talking about using state machines to model the emotional state of bots. Like when would they be cowardly versus when would they be aggressive, kind of thing.
Very cool. So one of the things that we get all the time asked at Game Dev HQ is the degree certificate in this industry. And as as an academic professor for a university and someone who's like the most current with Unity that they've ever seen from an educational level, what is your opinion on those who go this self-taught route and say, I don't need this degree, I can do this myself, or those who should go to college, get a degree, or get a certificate from a boot camp or anything like that?
So I think there's value in both. And in many ways, like I was self-taught because I started programming when I was 10, long before I actually got into uni. But so the way I would see the two, self-taught people, they have a passion, like a burning passion, typically, like that's why they stick with it and they pull something apart and they try to understand what's going on. Sometimes they're racking their brain and smashing them, like I was like that when I was 10, going up to, I started doing assembly at 16 and so forth. And I was like, why isn't this doing what I expect? And then the thing that a college or university will just help a bit, right, is they'll give you some structure, some way to think about whether it's some elements of problem solving, or they'll give you some theory. And as a big example, I did electrical engineering and I learned how to build communication systems, like the OSI 7-layer model of communication, like how to build protocols. And my first job, I was working at a company that was building an ISDN network card that would go into PCs. And the thing was, and then because we didn't have a system administrator, so I said, we need a server. So they said, well, you want it, build it. So I built the LAN server for everybody.
Wow, that is awesome.
And I had to learn IP. Like I would never touch TCP IP at uni, which is nuts.
So it comes down to being self-motivated, right? So like that's literally right. It comes down to being self-motivated. If you truly want this as a career for yourself, if you want this as a career path for yourself, you have the ability to make it happen. But I think we both agree that from a degree perspective, the degrees proven time and time again, they can open doors.
Yeah.
At the end of the day, your passion, your drive, your likability, that's what's gonna push you forward.
Yeah.
Cool. Exactly. All right. Well, hey, Warwick, we will close the stream up. Everyone has said literally just thank you so much. This was really awesome. I'm sure we'll have you back soon for another one of these. So thank you so much for your time.
No, thank you. It was awesome.
Cool. All right, guys. Thank you so much. Make sure you're in our Discord, and you'll be receiving an email for the recording of this, and we'll be posting it on our YouTube channel with all the links to Warwick's channel as well. So thanks, guys, and have a good one.